using theorem, limit extends to 0 sin x by x. This whole format becomes what? 1. This is wrong. Why? Because I am getting 0 by 0. Whenever you apply limit, you should never get 0 by 0. Inside sign, denominator and this. If these three are same and if it is tending to 0, answer is what? 1. So this is f of x into g of x. Then you apply limit for f of x into apply limit for g of x. Again in the place of x, if you put 0, it will become cos 0. Cos 0 is 1. 1 minus 1 becomes 0 by 0. Welcome to the session, dear students. Today we'll go ahead with the problems of limits and continuities, limits and derivatives. So now evaluate the following limit from the exercise 13.1, problem number 15. Limit extends to pi, sine of pi minus x by pi into pi minus x. Dear students, in the place of x, if you put pi, suppose in the place of x, if you put pi, what happens? Sine pi minus pi by pi into pi minus pi. So you know sin pi minus pi is sin 0 divided by pi minus pi is 0 into pi. Sin 0 is 0 and anything into 0 is 0, you will get 0 by 0. I taught you whenever you apply limit, you should not get indeterminate form. 0 by 0 is mathematical indeterminate form. So we are not supposed to get this. So remember, so this is not possible. So this is wrong. So therefore, we have to solve it. We cannot directly apply in the place of x. If you put pi, you will get 0 by 0. Whenever you apply limit, you should not get indeterminate. So we have to simplify this. So now we'll start the problem. So they want you to find, this is not possible as I told you. Why? Because here we are getting 0 by 0. So directly in the place of x, if you put pi, you will get 0 by 0. So we have to simplify the problem and then we should apply limit. So we'll take the problem, limit extends to what they give, pi, and they told sine of pi minus x divided by your pi minus x into what? Pi. Dear students, pi is a constant, you can take it out. So I can write 1 by pi outside. Pi is in denominator, this I'll take it out. What is left out? We are left out with limit extends to pi, sine of pi minus x divided by pi minus x. Again further, if you see this bracketed term pi minus x, I can assume it as theta, or bring, see, extends to pi, bring pi to LHS, it will become x minus pi tends to what? 0, or multiply minus on both sides, then it will become pi minus x tends to 0. So therefore I can write 1 by pi limit pi minus x tends to 0, sine of pi minus x divided by pi minus x. Now the problem is in the form of limit theta tends to 0 sine theta by theta. So you know the theorem. So what is the theorem we have learned? So we have learned a theorem. Theorem is what? Limit, sandwich theorem will say, limit theta tends to 0 sin theta by theta, value in maths is what? 1. Means this value and this value and this value are same and tending to 0, answer is 1. Here you can see pi minus x, pi minus x, pi minus x. You can also take pi minus x as theta. Then we'll get 1 by pi into theta. If you want to further simplify, you can assume or directly 1 by pi into, by using theorem, by theorem. So now in the place of pi minus x, if you assume theta, it will be sin theta by theta form. So this will become 1. So 1 by pi into 1 becomes what? 1 by pi. This is the answer. I'm using theorem. Limit extends to 0 sin x by x. This whole format becomes what? 1. Because these three terms are same. I hope all of you understood. First, pi is constant. Take it out. So it is in denominator, so 1 by pi, and apply limit for remaining part and bring pi to this side. So if x is tending to pi, bring pi to the side, x minus pi tends to 0, multiply minus on both sides, so pi minus x tends to 0. Now I made this term and inside sign, denominator and this. If these three are same and if it is tending to 0, answer is what? 1, by using theorem. What is the theorem? Limit x tends to 0, sin x by x is 1. So I am using this. So this and this values are same, means answer is what? 1. So here this whole thing becomes 1. We'll get the answer as 1 by pi into 1, that is 1 by pi. Next, limit extends to 0 cos x by pi minus x. Again, if you observe, Suppose if you apply in the place of x, if I put 0, I'll get cos 0 divided by pi minus 0. All of you know cos 0 is 1 by pi. So directly I am getting it. So no need to simplify. So this is possible. So I can say directly limit you can apply. Limit what is given? X is tending to 0. Cos x divided by pi minus x. What is meant by limit x tends to 0? In the place of x put 0. If you do that, you will get cos 0 divided by pi minus 0. You know cos 0 is 1. 1 by pi minus 0 is pi. So again answer is what? 1 by pi. All of you got it. So limit x tends to 0, cos x by pi minus x. In the place of x put 0. So it will become cos 0 by pi minus 0. Cos 0 is 1 by pi minus 0 is pi. 1 by pi. Next we have limit x tends to 0, cos 2x minus 1 by cos x minus 1. Here we'll try directly, we'll apply limit and we'll see what happens. Cos 2 times, in the place of x put 0, minus 1 divided by cos 0 minus 1. So cos 2 zeros are 0, it will be cos 0 minus 1 by cos 0 minus 1. You know cos 0 is 1 minus 1 by 1 minus 1. So it will be 0 by 0. Whenever you apply limit, you should not get mathematical indeterminate. So when you apply limit, you are getting indeterminate. So this is not possible. So this is wrong. Why? Because I am getting 0 by 0. Whenever you apply limit, you should never get 0 by 0. Since we are getting 0 by 0, we have to simplify. So now our task is to simplify and apply limit. So now let us take the problem. The problem given is, what they gave is, now we'll take the problem and we'll continue. That is the problem what they gave is limit x tends to 0. I told you directly in the place of x if you put 0, it will be 0 by 0. So I'll take cos 2x minus 1 divided by cos x minus 1. Now in the place of x will not put 0. Suppose if you put 0, what happens? It will become 0 by 0, and you know 0 by 0 is mathematical indeterminate. Whenever you apply limit, you should not get 0 by 0. So we'll simplify. I'll take minus common in numerator. So I'll write it as limit x tends to 0. Minus I'll take it out, so it will become 1 positive minus cos 2x. Similarly in denominator, I'll take minus common. So 1 will become positive and cos x will become negative. Further, I'll cancel minus and minus. Now I'm left out with limit x tends to 0, 1 minus cos 2x divided by 1 minus cos x. That is, further I can write limit x tends to 0, 1 minus cos 2x can be written as 2 sin square x. 1 minus cos x can be written as 2 sin square x by 2. Now I can cancel 2 and 2. I am using multiple angle formula. So please memorize this formula. We can derive it from cos 2 theta. So always remember 1 minus cos 2x gives you 2 sin square x. Half of this. And similarly 1 minus cos x in maths can be written as 2 sin square half of this. 2 sin square x by 2. If it is 1 plus cos x, it will be 2 cos square x. We can derive it. Now further we'll simplify. Here again in the place of x if you put 0, it will become 0 by 0. So that's why here I can see square. So divide numerator and denominator by x square. If you do that, I'll have limit x tends to 0. Numerator we have sin square x by x square. Denominator we have, what is the denominator? We have sin square x by 2. Sin square x by 2 by x square. Now we can apply limit separately for numerator, limit separately for denominator. Limit x tends to 0, numerator. What is numerator? Sin square x by 2. Sin square x square. And apply separately for denominator, that will be limit x tends to 0. Denominator is what? Sin square x by 2 by x square. Now apply limit. Now to apply limit, this is in standard form. So I can write numerator as limit x tends to 0. Sin square x by 2, can I write it as sin x into sin x? denominator x square, I'll write x into x. So divided by limit x tends to 0. Here I can write it as sine x by 2. Sine square x by 2 can be written as sine x by 2 into sine x by 2. But I have x square, x into x. So now extra term is here divide and multiply by 2. By 2 into 2. By 2 into 2. So now this product 2 2s are 4, you take it out. Numerator, when you apply limit for first term, limit x tends to 0, sin x by x is 1 into limit x tends to 0, sin x by x is 1. Dear students, if you have product of two functions, then you can apply limit for each function. Now this is f of x into g of x, then you apply limit for f of x into apply limit for g of x divided by here this 2 and this 2, take it out. So I'll take in 1 by 2, again 1 by 2, and I'll apply limit for remaining part. Limit x tends to 0, what is left out? I'm left out with sin x by 2 by x by 2 into sin x by 2 by x by 2, this term. Dear students, if x is tending to 0, divide by 2 on both sides, x by 2 tends to 0 by 2, that is again 0 only. So now 1 numerator is 1 divided by 1 1s are 1, by 2 2s are 4, and this x by 2, limit x by 2 tends to 0, sin x by 2 by x by 2 into sin x by 2 by 2. So now you can apply limit separately. So that is 1 divided by 1 by 4 into, so limit x by 2 tends to 0, sin x by 2 by x by 2 is 1. Again sin x by 2 by x by 2 is also 1. So 1 by 1 by 4, 1 by 1 by 4 is what? 4. 4 is the answer. So finally you will get what? 4. I hope all of you got this. And then limit x tends to 0, they give ax plus x cos x divided by b sin x. So dear students, we can split this. We have two techniques to solve. I'll take x common, then it will become a plus cos x. Then the x you can rearrange. So directly in the place of x, if you put 0, this will become a zeros are 0. This will become 0 into anything 0. This will also become 0. Directly in the place of x, if you put 0, you will get 0 by 0, which is mathematically indeterminate. So there is necessity to simplify this. So how to simplify? You can see x is common in numerator. So here I have x, here I have x. I'll take x common. If I take x common, what is left out? A plus cos x divided by what is left out? B sin x. And this into x, I can transfer it to denominator. Further, I can write it as limit x tends to 0, a plus cos x divided by I have b sin x. See, into x, this numerator, can I write it as denominator of denominator? So I'll write it as by x. Now I'll apply limit separately for numerator, limit separately for denominator. So you know, if you have f of x by g of x, you can apply limit separately for numerator. Numerator is a plus cos x. And then I'll apply separately for denominator. Denominator is limit x tends to 0. That is b sin x by x. Now numerator we have limit x tends to 0, a plus cos x. Denominator we have limit x tends to 0, b sin x by sin x. This is what is left out. Now in the place of x, put 0 in numerator. So it will become a plus cos 0 divided by b is constant. Take it out. Apply limit only for the remaining part. X tends to 0, sin x by x. This is by theorem. Numerator is a plus cos 0 is 1. B into what is limit x tends to 0 sin x by x? Theorem. According to sandwich theorem, limit x tends to 0 sin x by x value is 1. So numerator is a plus 1, denominator is b. This is the answer. I hope all of you got this. So in the place of x, if you put 0, cos 0 is what? 1. But here in the place of x, you don't put 0, it becomes 0 by 0. But you know, limit x tends to 0 sin x by x is 1. Limit x tends to 0 tan x by x is also 1. So this is the answer. Now limit x tends to 0 x secant x. limit x is tending toward 0, x into secant x. All of you know, I can write secant x as what? Reciprocal of cos x by cos x can I write? Why? Because now I can substitute. In the place of x, I'll put 0, 0 divided by cos 0. See, I'll not get 0 by 0. 0 divided by cos 0 is 1, 0 by 1 is 0. You can get the answer as 0, but you should not get the answer as 0 by 0. So, into secant x was there. Directly secant 0. Secant 0 is also 1, 0 into 1. Directly you can apply 0 into 1. 0 into 1 is 0, or 0 by 1 is also 0. You can get. Next we have limit x tends to 0, sin ax plus bx by ax plus sin bx, where they told a is not 0, b. So, these are not zeros. This is a condition they give. So, now this is the problem. Dear students, again in the place of x, if you put 0, in the place of x, if you put 0, sin 0 is 0, b into 0 is 0, and this is 0, so you will get 0 by 0. So, you should not get 0 by 0 means you should simplify. So, what we do is limit x tends to 0, sin ax plus bx divided by ax plus b sin bx. So, divide numerator and denominator by x. The very first step is divide numerator and denominator by x, so that the problem simplifies. So, the given problem reduces now. So, given problem, limit x is tending to 0, and we'll have sin ax plus bx by x divided by denominator also ax plus sin bx by x. Now split this. If you split, it will become limit x tends to 0. Numerator you can write it as sin ax by x plus bx by x. Similarly, denominator limit x tends to 0. We'll have ax by x plus sin bx by x. Now further you simplify, so it will become limit x tends to 0, sin ax by x plus, apply limit for each term, limit x tends to 0, bx by x. So you know bx by x, x cancels. Denominator limit x tends to 0, apply for each term, that is ax by x plus limit x tends to 0, sin bx by x. Here you can cancel x and x. Here sin theta by theta. Here ax is there, but here we have x. So divide and multiply denominator with what? A. So can I write it as limit x tends to 0, numerator sin ax divided by x is there. I'll multiply a and this a into a. So a you can cancel. Then similarly this limit x tends to 0, b is there. Here we don't have x to put 0, so it is b. Limit of constant is constant. So x tends to 0 means in the place of x put 0, x cancelled. We don't have x, so it will be b. Denominator also. Here you can see limit x tends to 0, a is what? A only. If there is x, you put 0, but x is cancelled. So limit x tends to 0, constant is constant. Now here b by x, bx by x, and inside we have bx, but denominator is x, so introduce b. So I'll write limit sin bx, x is tending to 0, divided by x we have, divided and multiply by b. Further simplify, numerator is a, you take it out, apply limit only for what? X tends to 0, sin ax divided by ax. Denominator, this is a plus b, you take it out, so it will become limit x tends to 0, sin bx by b. Now that is numerator is a into 1, denominator is, sorry, b, here we have plus b outside, then plus b, and this is a into b into 1. So numerator is a plus b, denominator is also a plus b. A plus b cancels and you'll get 1. So 1 is the final answer. I hope all of you got it. Now limit x tends to 0, cosecant x minus cot x. So in the place of x, if you put 0, cosecant 0 is not defined and cot 0 is not defined. Infinity minus infinity does not exist. Suppose in the place of x, if you put 0, it will become cosecant 0 minus cot 0. So cot 0, it is not defined, minus not defined. This is mathematical indeterminate. This is not possible. So that's why we need to simplify. First, we'll take the given problem, that is limit x is tending towards 0. Cosecant x can be written as 1 by sin x minus cot x can be written as cos x by sin x. Now we'll take LCM. So the given problem I wrote like this. Now we'll take LCM. So limit x tends to 0. What is the LCM for these two? Sin x is the LCM. Numerator becomes 1 minus cos x. Again, in the place of x, if you put 0, it will become cos 0. Cos 0 is 1. 1 minus 1 becomes 0 by 0. So again, it is giving you indeterminate directly. If you try putting x as 0, it will become 0 by 0. So that's why we should simplify. So we'll take limit x tends to 0. 1 minus cos x by sin x. So 1 minus cos x can be written as, we'll use multiple angles. I already taught you 1 minus cos x can be written as 2 sin square x by 2. And sin theta can be written as 2 sin x by 2 into cos x by 2. I am using multiple angles. I am using sin theta. Sin theta in maths can be written as 2 sin, half of it. 2 sin theta by 2 into cos theta by 2. Cos theta by 2. And 1 minus cos theta can be written as 2 sin square theta by 2. So here we have 1 minus cos x, 1 minus cos x, I am writing it as 2 sin square x by 2. Here I have sin x, I am writing it as 2 sin x by 2 into cos x by 2. 2 cancels, sin x by 2 cancels. I am left out with limit x tends to 0, sin x by 2 by cos x by 2. Dear students, in the place of x, if you put 0, the numerator becomes 0, denominator becomes 1. 0 by 1 is 0, that is possible. So now I can write sin 0 by 2. This is cos 0 by 2. Further, sin 0 by 2 is sin 0 divided by cos 0. You know, sin 0 can be written as 0 by 1. 0 by 1 is 0. So limit gives you 0. You can get 0, but you should not get 0 by 0 or infinity minus infinity. So therefore we simplified. Or further, here I can write tan x by 2. In the place of x put 0. Tan x by 2 is tan 0 by 2. Tan 0 is what? 0. So we use multiple angles. 1 minus cos theta can be written as 2 sin square theta by 2. Sin theta can be written as 2 sin theta by 2 into cos theta by 2. 2 cancel, sin cancel. So sin by cos, tan directly here. The other alternate is, so here once you get limit x tends to 0, we are left out with sin x by 2 by cos x by 2, right? So now you know sin by cos in maths can be written as tan. So I can write it as limit x tends to 0, tan x by 2. So tan x by 2 means in the place of x put 0. That's what is left out, right? Yeah. So now tan 0 by 2. Tan 0 by 2 is what? Tan 0. Tan 0 is what? 0. So however you do, you will get the value as what? 0. So I hope all of you understood the problems whatever we discussed. We reduced many problems to the form limit theta tends to 0 sin theta by theta, and we have solved. Please sit and practice the problems. I'll see you in my next session. Thanks for attending. Thank you.